Okay, it's been quite the learning experience for me as I'm using new software because I'm stuck at home with Ruthie. It's a little bit under the weather today. So, nevertheless, I've learned a lot today. Hints for questions 1 and 2. Question 1, we're looking for the minimum coefficient of friction. So if we're looking for that, that really means we're solving for mu. And we've got in this equation, in the end, what we got to do is solve for mu. And if we rearrange the old fun equation, we know that the force of friction divided by the normal force is going to give us our mu. So now the question becomes, how do we find force of friction and the normal force? I'm not going to address normal force. I'm going to leave that to you, but I am going to talk just a little bit about friction because we were cut short. So as we go around a circle, or around a turn in this case, with some velocity, right? Our car, because of inertia, would like to just follow this path tangent to the curve. However, the car follows the curve instead. That means that something is pulling the car towards the center of that circle. That something is technically called a centripetal force. And in this case, what's holding it towards the middle is actually the interaction between the tires and the road, which generically is called the force of friction. Based on Newton's second law, we know when we're trying to calculate how much force is required, we have to consider how much mass an object has and how much you're trying to get that object to accelerate. In this case, we're not speeding up or slowing down for acceleration. We are changing direction, so this is a centripetal acceleration. If only we knew the centripetal acceleration, well, this problem would be a whole lot easier. Unfortunately, we have to solve for it. So we have to look at, and this is a textbook physics problem, so we know the information is given to us, we just sort of have to figure out what form it's given to us. So we say, what is it? How do you calculate centripetal acceleration? And you know from our equation the other day that you can calculate centripetal acceleration as velocity squared, whoops, wrong one there, velocity squared divided by the radius. And so now I think you have enough to calculate the centripetal force, and also that will then lead you to the force of friction. You can do normal force and hopefully end up around this answer for your mu. Question number 2 is a little bit different. This is kind of an interesting problem where they give us a situation. They're trying to simulate half of the Earth's gravitational force. So really what that's saying is we want to find an acceleration that is 0.5 g, right? Where little g is our acceleration due to gravity. They also tell us that this thing will spin at 5 revolutions per minute. So think for a second, 5 revolutions per minute. Is that the period of oscillation or is that the frequency? You're so smart. It is the frequency, yes. So the frequency is 5 revolutions per minute. Unfortunately, that's not MKS, meters, kilograms, seconds. That's minutes. So we've got to change that, and I'm going to leave this to you to figure out how many revolutions per second that would be. And second unfortunate situation here is that we probably aren't going to need frequency. Rather, we're going to need the period. And the period, as you can remember, is the reciprocal of the frequency. So with those two things in mind, I will then ask you to consider 2 equations. One, the equation for centripetal acceleration, which is equal to v squared divided by r, and the equation for velocity in a circle, which is 2 pi r divided by the period. Hopefully with that you'll be able to do a little substitution, rearrangement, and isolation so that in the end you can solve for the radius of curvature and you end up somewhere near 18 meters. Hope this helps. Have a great day. Good luck.